Welcome to this introduction of the two-finger method. The two-finger method is a perfectly general and very powerful way to multiply two numbers. It was developed by a Jewish mathematician, Jacob Trachtenberg, in his detention in German concentration camps during the Second World War. Unfortunately, his method has never really been recognized for what it's worth. This exposure is an attempt to show to a large community what they have been missing. But allow me to first introduce myself. My name is Jan de Jonge. I am a professional software designer and I take a keen interest in math education, especially with respect to people with learning disabilities. At the age of 15, I was first introduced to the two-finger method. Though I have never become a real good mathematician, this method has helped me tremendously and I have been able to help others improve their math. The two-finger method is generally regarded as a Vedic calculation technique. Such techniques aim at enhancing several cognitive skills such as concentration, memory usage, and mental agility. Improving math is not necessarily the principal objective, but it is of course a very convenient side effect. Numbers are dealt with in a way that always works. All you need is paper and pencil, and any normally intelligent 10-year-old child can easily learn it. Moreover, a remarkable feature of this method is that it entices the student to improve his or her performance. Now let's meet the rules of the game. Basically, there are 4 rules and they are all presented here in one line. I will first discuss them individually and then we will see how they work in examples. The first rule is put the largest number left of the cross. Then connect a right-hand digit to 2 left-hand digits by using a so-called rake. The rake has 2 fangs, each of which refers to a digit multiplication. A digit multiplication is an elementary multiplication of 2 digits from 0 to 9. Any digit multiplication results in a 2-digit number. This is also the case when the result is smaller than 10. When that happens, just prefix a 0. So, now we always have 2 digits, and we call the first one the multiples of 10 digit, and the second one the unit digit. The fourth rule gives the result of this step. Add the units of the left multiplication to the multiples of 10 of the right multiplication. Often this is referred to as adding the inner digits. You can also see that in the upper line in the underscored digits. These 4 rules apply to one step of the multiplication of 57 and 3. The complete multiplication of 57 and 3 consists of 3 steps. As you see, the rake shifts over 3 successive positions from right to left. Please join me. The inner digits of 21 and 00 add to 1. Those of 15 and 21 give 7, as we have seen, and 00 and 15 once more result in 1. Here we have a 4-digit number. We'll carry it out step by step, but first notice the result of step 2. 6 and 4 add up to 10, but since this is more than 1 digit, we register it as a 0 with a dangling 1. This one we call the carry. It serves as a reminder that has to be added to the next result we write down. When you look at the calculation, it is rather elaborate and hardly fast. But please bear with me. It was necessary to do it this way in order to show you the details. From now on, we are going to speed things up. A first obvious step is to avoid redundancy by only once writing the problem. You will quickly see there is no need to state the problem on a new line for each step. Next, I introduce the notion of seeing. What I mean by this is best explained by referring to reading. When you read a paper or a book, you do not pay attention to each letter or sign. A word like yesterday is grasped as a whole, that is, as a word, not as a collection of individual letters that every time needs to be assembled to a word. The idea behind grasping bigger chunks of information is that you not only better concentrate, it also speeds up the process and improves the oversight over what you are actually doing. Now we are going to apply this to arithmetic. When you see two digits, you must see what their product is. So, if you have to multiply 7 and 8, you see 56. You are not going to perform the multiplication, you just see 56. But we take this a step further. By using the two-finger method, you actually never need 56. You only need the 5 or the 6. So, you should briefly see the shadow of 56, and you pick 5 or 6 according to your needs. The third aspect of the acceleration has to do with what you mention, aloud or internally. Do not mention anything but results. And what we mean by that, you'll see in the next example. Here we have replaced the rake with two dots. If you write down the problem on paper, you can have two pencils to point to the dots, or two fingers, whence the two-finger method. Now, let's carry out the steps without naming any table multiplication, that is, by strictly mentioning results. First we get 2, and since this is the result of the first step, we write it down. At the next step we mention 6, 10, and write down a 0 and a 1 as carry, as we've seen. Then 7, 12, 13, write down 3 and again 1 as a carry. Now 5 stays 5, 6. We end with 3. What have we been doing? First, we break down a multiplication in steps. Then we apply rakes, and per rake we add units and multiples of 10. We started to write down intermediate results, and later we only mentioned running results. Let's take a look at what we've achieved so far. We've only barely scratched the surface, and you have not yet seen how to directly write down the answer of a large multiplication. Even for 10-year-old children, it takes 5 lessons to do that. But what you have seen is that this calculation technique works. You have also seen that as you gain momentum, your thoughts do not wander off, and it is easier to remember where you are in the calculation. Although calculation speed is no goal in itself, it is undeniable that speed, concentration, and memory usage reinforce each other. The result is that the student becomes more comfortable with numbers, gets a feeling of control, and significantly improves his or her number handling.